So section 2.5, synthetic division. We have this remainder theorem. I'm going to talk about this in just a moment. I'll get back to this, but let's do a couple of things here. First of all, let's do this problem in long division. Okay, so I want to divide x minus 2. I want to divide that into 2x squared minus 3x minus 2. So the first step is what? What do I multiply x by to get what? 2x squared. So what is that? 2x. Okay. Then I perform that multiplication and I get what? 2x squared minus 4x. And then I take whatever's on that line and I have to make sure I subtract it. So 2x squared minus 2x squared is 0. What is negative 3x minus negative 4x? That's just x. And then I've got a minus 2 here. What do I multiply x by to get x? 1. And then when I multiply this, I get x minus 2. When I subtract those things, I get 0. Okay? So pretty straightforward. So my remainder is what? 0? So it means that x minus 2 is a what of the original? It is a what? It is a factor. So x minus 2 is a factor of f of x. Okay? So that means that the answer to this problem, this is what? What's the answer to that division? 2x plus 1, right? And I can write f of x is 2x squared minus 3x minus 2. It's also the same as x minus 2 times what? Times 2x plus 1. Okay? Because the x minus 2 divides out evenly and I get a 2x plus 1, these two things are factors. Factors can multiply. So when I multiply those two things together, I will get this original expression here. Now what's the remainder? 0. Okay? So the other thing, what happens if I plug a 2 into this? What do I get? 0. Because if I plug a 2 in, this factor becomes 0. What the remainder theorem tells me is that if I divide a polynomial by x minus a, the remainder is f of a. It's the same as substituting the value a in. So I divided here by x minus 2. That's the same thing as plugging a 2 into the original equation. Because we realize that if I plug in a 2 here, I get a 0. So in this case, I had a 0 remainder. Okay? So what we're after here is that doing a division is the same as substituting a value. Okay? So you'll see it a little bit more when we do synthetic substitution here. So let's look at synthetic substitution. So remember, find the value of f of 2. Remember the way we did this. I put a 2 here, and then I copy down all the numbers of this coefficient. So that's what? 2, negative 3, and negative 2. The 2 corresponds to my x squared, that's my x, and that's my constant. Okay, what's the first step in doing this? We've done this, right? Bring the 2 down, that was what this big arrow was, and then what? 2 times 2 is 4. What's 4 minus 3? 1. What's 2 times 1? It's 2. And I get a 0. Okay? So this tells me that f of 2 is what? Is 0. Okay? Now if you look at things like here there was a negative 3 and a positive 4, okay, that it got added together. Didn't that same thing happen over here? When I got to this step, right? This is a positive 4 and a negative 3, okay? Right? If you look at the other thing here, the answer here is 2x plus 1. If this is an x squared, what if this were x and this were a constant and this were my remainder? What does that mean? This is what? 2x plus 1. Okay? So you can use synthetic substitution, sometimes called synthetic division, to do this same problem. All you're doing is using the coefficients, okay? So all I did here was, when I try to find the value of f of 2, that's the same as trying to figure out, is x minus 2 a factor, okay? So you need to be able to go back and forth between, if I'm trying to find out if x minus 2 is a factor, that's the same as trying to find out, is 2 a root or a solution? So substituting the value of 2 in there. Because if x minus 2 is a factor, I can plug in a 2 and I'll get a 0 for a remainder, okay? So if I get a non-zero remainder, what I'm testing is or is not a factor. If it's a non-zero, if the number is not 0 here, if I get a remainder that's not 0, did I find a factor? No, okay? So that's what we're after with synthetic division. So what we did here was the same thing. This was dividing this polynomial by x minus 2. These are both the same operations. Which of these is easier to do? One on the left or the right? The one on the right. This is easier to do. So what we're going to do from now on is to use synthetic division. So here I found that x minus 2 is a solution or root, okay? These are all the same thing. A solution, a root, a 0, okay? So let's look at a few examples. Use synthetic division to divide 3x cubed minus 2x plus 7 by x plus 2, okay? So I'm after, this is the operation they want me to do. They want me to do 3x cubed minus 2x plus 7 over x plus 2. So what I'm trying to test here, I'm trying to figure out, is x plus 2 a factor? So is x plus 2 a factor? That's the same as x equal negative 2 a solution. These are the equivalent questions. Is x plus 2 a factor, or is x minus 2 a solution? Okay? So to do it with synthetic division, which of these numbers, what do I do? How do I set up the synthetic division? I'm testing whether something is a root or solution. What number am I testing? Negative 2. So that's very important. If I'm trying to divide by 2, my synthetic division starts with a negative 2. Okay, I'm testing whether or not negative 2 is a root or solution. Then I write down all the coefficients. 3, negative 2, and 1. What's the mistake that people make in the setup? Yeah, forgetting if you have to put a 0. So this is my x cubed. That's my, so you look, I made the mistake. There's an x squared term there. So I got to back up. So there is an x squared, an x, and a constant, okay? So I had that set up wrong. So there's 3, there's a 0 for the x squared term, a negative 2 for the x, and a 7 for the constant, okay? If you make this mistake, like I just did, and I made it honestly there, there's no clue that you made the mistake. You're just going to get the wrong answer, okay? There's nothing that's going to just not work out for you. You're just going to get the wrong answer. So that's why sometimes, and it will help you if you're setting it up, if that's an x cubed, write down everything that has to be there, okay? First step is to do what? Come on, guys. Bring this 3 down. Negative 2 times 3 is what? Negative 6. Add those numbers to get negative 6. Negative 2 times negative 6 is 12. 12 minus 2 is 10. Negative 2 times 10 is negative 20. Add that to 7, I get negative 13. So this is my x squared term. That's my x. That's my constant. And that's my remainder. So everything decrements by 1 in terms of the degree from the original polynomial. So what is the answer to this division? 3x squared, yeah, 3x squared minus 6x plus 10 minus 13 over what? X plus 2. So is x plus 2 a factor of that original? No, it's not a factor because I did not get a 0 remainder. Okay? So the key in setting up synthetic division, whenever you're looking at a factor, is the opposite sign of this is what you're testing to be a root or solution. So I'll set up the synthetic with this. Make sure you have a place for every degree of the polynomial. Okay? So we have a couple here. Okay, the first one, when I set it up, I'm dividing by x plus 2. So what's going to go outside the synthetic division? What number? Negative 2. Okay, so negative 2. And then I need, since this is an x cubed, I'm going to need an x cubed, an x squared, an x, and a constant. Coefficient of x cubed is 1. X squared is 4. Negative 1. Negative 1. So if I bring the 1 down, what's 1 times negative 2? Negative 2. 4 minus 2 is 2. Negative 2 times 2 is negative 2. Add those to get negative 3. Negative 2 times negative 3 is 6. Add that to get 5. So is this a factor? It is not. This corresponds to my x squared. That's my x. That's my constant. And that's my remainder. So the answer to this division is what? What's the answer? You read it off the bottom row. X squared plus 2x minus 3 plus 5 over x plus 2.
So Jordy, how about the x squared where you brought down the 2? Wouldn't 2 times negative 2 be negative 4?
Oh, did I make a mistake? You're right. So I got to back up. So that's an example of me just getting the wrong answer. So let me back up. Is that why you guys were quiet? Because I made a mistake? Come on. Yeah, come on. I'm not going to give you all of that. So if you should catch it when I do it. Negative 2 times 2 is negative 4, right? You add those and you get what? Negative 5. Multiply these numbers and you get 10. 10 minus 1 is 9, okay? You didn't change the fact that it's a factor or not. So now the answer is what? X squared plus 2x minus 5 plus 9 over x plus 2, okay? So x plus 2 is not a factor. How do I know it's not a factor? My remainder was not 0, okay? Let's look at this next one. When I set this up, what's the number that goes outside the synthetic division? Positive 3. I'm testing, is x minus 3 a factor? That's the question I'm trying to ask myself. Or is x equal 3 a root or solution? Okay? That's what I'm trying to figure out here. Is x minus 3 a factor? If it was, then x equal 3 is a solution. So let's write down the coefficient of my x cubed. So I get 2, negative 11, 3, and 36. So this is my x cubed, my x squared, my x, and my constant. Okay. So the 2 comes down. 3 times 2 is 6. Negative 11 and 6 is what? Negative 5. 3 times negative 5 is negative 15. Add that to 3 and I get negative 12. 3 times negative 12 is what? Negative 36. Add that to get 0. What does this mean? Yeah, x minus 3 is a factor. X equal 3 is a root or a solution. Okay, so this corresponds to my x squared, my x, and my constant. So what is the answer to this division? It's when I divide these two, what's my answer? You read it off of the bottom line. 2x squared minus 5x minus 12. Okay, in doing the next one here, when I set this up, I'm trying to ask myself, is x plus 1 a factor, or is what a solution? Is x plus 1 a factor, or I'm trying to test if x equal what is a solution? Negative 1. So these are equivalent questions. Okay, is x plus 1 a factor? Is x equal negative 1 a solution? To do synthetic division, I use this solution part. So I put a negative 1 here, and then I write the coefficients of every term. X to the fourth, x cubed, x squared, x, constant. What's the coefficient of x to the fourth? 1. X cubed, 0. X squared, 4. Negative 1, negative 1. So if I bring the 1 down, 1 times negative 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is 1. Add that to 4 and get 5. Negative 1 times 5 is negative 5. Add that to get negative 6. Negative 1 times negative 6 is 6. And I get a 5. Is x plus 1 a factor? It is not a factor. So this corresponds to x cubed, x squared, x, constant, and remainder. So what is the answer to this division? How do you read the solution off the bottom line? That's what? X cubed minus x squared plus 5x minus 6 plus 5 over x plus 1. Okay, is this too easy for you guys? I mean, not getting a lot of feedback here. So you've done the synthetic substitution before. You need to get very comfortable with it because there are times when I'm going to need to try this 3 or 4 times on a problem. And this is quicker than trying long division 3 or 4 times. Okay? Because what we're after is, in order to factor these polynomials, I need to be pretty quick with synthetic division to see if something is a factor. So in this case, I know just by this, x plus 1 is not a factor. And how do I know that? Because I got a remainder that was of 5, a non-zero remainder. So in the next one, when I set this up, what goes outside the synthetic division? What number? 2. Okay. So what I'm testing here is x minus 2 a factor? Or is x equal to a solution? That's what I'm testing. So I write a 2 here. And then I write all the numbers that correspond. So this is x to the fourth. I need an x to the fourth, an x cubed, an x squared, an x, and a constant. Coefficient of x to the fourth is 1. S cubed is 3. What about x squared and x? Yeah, 0, 0, negative 28. If you miss those zeros, you're going to miss the entire problem. Okay? So if I bring the 1 down, 1 times 2 is what? 2. Add those to get 5. 2 times 5 is 10. Add that to get 10. 2 times 10 is what? 20. You add that to get 20. 2 times 20 is what? 40. And 40 minus 28 is what? 12. So is x minus 2 a factor? Yeah, it is not a factor. This is your x cubed, your x squared, your x, your constant, and your remainder. So x minus 2 is not a factor. And then the answer to f of x divided by d of x, what is the answer? Yeah, x cubed plus 5x squared plus 10x plus 20 plus 12 divided by what? X minus 2. Okay, there we go. Okay? And that should be it for today. So, guys, one of the things in setting up synthetic division, just be very comfortable with, and you'll see why this makes more sense later, like, is this a factor? Is this a solution? Be comfortable going back and forth between, if I'm testing for this be a factor, I'm testing if this is a solution. The solution one is the one that goes outside the synthetic division. Okay, so if I'm dividing by x minus 4, it's a 4 on the synthetic division. If I'm dividing by x plus 4, it's a negative 4 on the synthetic division. And then make sure you have placeholders for everything that's in the problem. Okay.